So, you've been wanting to come into data science and machine learning. We'll be talking about linear regression today. And you can consider this as your introduction into the clique of high salary earners. Of course, that seems to be the only motivation for people to want to pick up new skills today. Linear regression belongs to the class of numerical method called curve fitting. In data science, it belongs to a class of machine learning algorithms called supervised learning. And as the name suggests, the algorithm is learning from humans. And the learning is supervised because the data that is being used contain labels for features in the dataset. So by the labels, so humans already informed the algorithm that this is the solution or the label for this set of features. So what you have to do is to learn how to predict the label from the features. So which means the algorithm is trying to mimic human by using the solutions already provided by human, and that is why it is called supervised learning. So before we go on further, I urge you to hit the like and subscribe button and smash the notification bell so you'll be the first to be notified when a new video is uploaded. So the reason that we embark on any activity is to gain insight or to earn monetary reward from that activity. So in linear regression, it turns out that what we are actually looking for is to gain insight into future behavior of some physical systems. I mean, the physical system could be dealing with unemployment in a country. That is, if you're the Minister of Labor or the Minister of Finance. If you are the public health official, for example, maybe the Minister of Health, you might be interested in the rate of hospitalization of patients for a particular disease, in which case you are interested in having the ability to predict how much people will be hospitalized from this particular disease in the future, just so that you can prepare the government and then prepare the hospitals and get the necessary drugs that you need for treatment, and then possibly sensitize the people about their behavior so that you can lower the hospitalization rate. So, in any of this situation, what is important is your ability to understand the data and be able to make predictions. And for you to do that, we are going to start with linear regression. So we're going to be looking at three classes of models that will apply linear regression to. So the first one is the standard linear form. Then the second one will be of the exponential form. And then the third one is the power law. The choice of which one you apply here depends on your knowledge of the domain that you're dealing with. What that means, a good data scientist must understand the field that is applying its data science skills to. So let us start with the first part, the linear regression. So the first thing I'm going to do here is to create my domain, which is the extreme that I'm dealing with. So I mean, it's randomly generated set of doubles, so create the y, which is a linear model with some random numbers added to it. So then I'm going to make a plot. So this is my data. So right here, I have 20 set of random numbers. All right, so between 0 and 100. And then I have the model, which is actually 3x plus 5. But in reality, you don't know the equation, the linear equation that produced the data set. So you have just have the x and then you have the y, and then you need to fit it with using linear regression. Matrix A. So matrix A is a horizontal concatenation of 1 and the value x. But that one must have the same size as x. So once size of x. And then I concatenate that with x. The next thing I can solve for the parameter. So here you can see we're using the backslash, and then MATLAB backslash already has the ability to solve both adequately determined linear system and over-determined system. And linear regression is an example of over-determined system. So there is more than just LU factorization that is going on here. So first, there is A transpose Y and A transpose A. So, and then that is the equation that is solved. But let us forget about that detail for now. So just know that you are looking at this problem as if it is AX equals to B, and then that B is Y. So, and then the X is par, which is the parameter. Then you solve that, you get your results. So now let us now perform the estimation and then plot that on the same axis so that we can see how it looks like. So to do that, we have this. Let us run this section and then see the plots. So this is your results. So this is your linear regression. It's a straight line. So this is your linear regression, and you can see how it closely fits the data. Okay, fine. Sometimes we like to have a kind of an estimation of how good the fit is. For that, we do what we call correlation coefficients of regression. So to do that in MATLAB, you use the call coef. So and the argument that you passed is the y estimate and the initial y that you were given. So when the result is out, you can pick the second index element and then square that. That gives you the R square value of this fit. So let us run this section and then see the results. So here I have placed the results on the same axis, and that is 0.98125. So this is how to do linear regression in MATLAB. But let me add one more thing. Now, you can do this without actually making this matrix A yourself. There is a general method that can handle that in MATLAB. So let me quickly introduce you to that. Let us create another section. And that function is called the polyfit. So to use the polyfit, you just pass your x and y, and then you pass an additional parameter 1. So 1 tells polyfit that I am fitting a polynomial of degree 1 to this data. So the next thing we do is to estimate our parameter. So, I mean, estimate the y because we already have the parameter. So I call this parameter par p, just p to say that I'm using polyfits for polynomial fits. And then, so y estimate, I'm going to add p to that also. So in this case, I'm using the polyval, that is, that estimates the value of a polynomial using the polynomial coefficients and then the x value. So the next thing I'm going to do is to plot, but this time around as I'm plotting, I'm going to use a thicker width just so that we can see this new plot, all right, separately. Or maybe I can even use a different let's say I can use a different line style. So let me say this. We are going to see that on this. And then so that we'll see that one and then we'll see the other one inside. And then let us now also add this own correlation of regression and then display it at a height of about 100 instead of 150 so that it will be below the other one so that we can see everything. So this is it. So now let us run this section and see the results. So here is the results. You can see this red line here. You see the red line here, so which means the other one is inside it. All right. So you can see the red line, and then you can see the yellow line is covering the red line, which means they are exactly the same thing. And when you look at the R square value, they are still the same. So at this point, this video is kind of feeling like it's getting too long. So I'm going to break it into two. Then, so I'll be discussing the exponential and the power law fit using linear regression in the second half of the video. So see you then.